You ever notice an ingredient that seems to be hiding in plain sight? It's in some of our oldest foods and our most modern supplements. But here's the twist. How it's made can completely change what it is. All right, let's get into it and solve the strange case of soy protein.
So, first things first, let's just establish how incredibly common this stuff is. You might think you know soy, but its reach is probably way wider than you imagine. It's a true master of disguise in our day to day lives.
Okay, so you'll definitely find it here. In a ton of sauces and savory foods, it's used as a major flavor enhancer. It's what gives you that rich, deep umami flavor we all love. It's basically the backbone of that savory kick.
No big surprise here either, right? For years, it's been a go to for athletes and health nuts as a super high quality plant based nutritional powerhouse. It's really a cornerstone of the whole supplement world.
Hold on.
What?
Yeah, you heard me right. It's in your shampoo. And this is where our case starts to get really interesting. The very same base ingredient is used in hair care to strengthen and repair damaged hair. So, that's the big question, isn't it? How can one single ingredient be a flavor booster, a muscle builder, and a hair strengthener all at the same time? Well, the secret isn't really in the ingredient itself, but in how it's treated. To really get why it's so versatile, we have to look at a key chemical process. It's all about taking something big and clunky and breaking it down into something our bodies, and yep, even our hair, can actually use. That process is called hydrolysis. Now, the simplest way to think about it is this. Imagine a protein is like a long, tangled up ball of yarn. Hydrolysis is like taking scissors and snipping that yarn into lots of little, usable pieces. Those little pieces are called peptides and amino acids, and they're way, way easier for us to absorb. This is a perfect analogy. A regular protein molecule is kind of like a basketball. Now, try shoving that basketball through a tiny keyhole. It's just not going to fit. But hydrolyzed protein, that's more like sand. The tiny particles can slip right through that keyhole, filling in all the gaps and making the structure stronger from the inside out. And that's true whether we're talking about a strand of your hair or your own digestive system. And this is where our little mystery takes a sharp turn, because it turns out there isn't just one way to hydrolyze soy protein. Nope. There are two very different paths a company can take, and the path they choose makes all the difference in the world. So on one hand, you've got acid hydrolysis. Think of it as the fast and furious method. Strong acids, high heat, just get it done. On the other hand, you have enzymatic hydrolysis, which is way gentler. It uses specific enzymes under milder conditions. And this isn't just some tiny technical difference, it completely changes the final product, right down to the aromas it gives off. Now, that rougher, acid-based process, it comes with a potential catch. When you use that much heat and strong acids on vegetable proteins, you can sometimes create some unwanted side effects. One of those side effects is a contaminant called 3-MCPD. It can form when leftover fats in the soy have a chemical reaction with the acid used in the process. It's actually a pretty well-known issue, and food safety agencies keep a really close eye on it. In fact, the FDA has set up specific guidelines for it. For both these acid hydrolyzed proteins and the Asian-style sauces that often use them, the limit is 1 part per million. So this just shows that regulators are on top of it and have clear safety rules in place. And just to give you a little more context here, the International Agency for Research on Cancer classifies 3-MCPD as a Group 2B agent. All that means is that it's possibly carcinogenic to humans, based on studies in animals. And that's the main reason why manufacturers work so hard to keep the levels as low as they possibly can. Okay, but let's pivot for a second, because that's only one side of the coin. While the acid process has its issues, soy protein itself, especially when it's processed a different way, is an absolute nutritional superstar. So to measure how good a protein is, scientists use something called a PDCAS score. It's the gold standard. It doesn't just look at how much protein a food has, it scores how complete its amino acids are, and, this is key, how well we humans can actually digest and use it. The scale goes from 0 all the way up to a perfect score of 0.1. So what about soy protein isolate? It gets a perfect 1.0. And let me tell you, for a plant-based protein, that is a huge deal. And this chart just brilliantly illustrates how impressive that score really is. Soy protein isolate is right up there, shoulder to shoulder, with top-tier animal proteins like chicken. It scores way higher than other popular plant proteins like pea, and it just dwarfs something like peanut butter. It is one of the only plant proteins out there that can hit that perfect score. So there you have it. The verdict is in on the strange case of soy protein. We've seen two completely different characters come from the exact same starting point, and it all boils down to the journey it took to get here.
At the end of the day, when you see hydrolyzed soy protein on a label, that name just doesn't tell you the whole story. Was it made with that harsh, high-heat acid process that gives you intense flavor but might carry a contaminant risk? Or was it made with the gentler, enzymatic process that gives you a nutritionally perfect protein? The method really does define the ingredient.
And that kind of leaves us with a final thought, right? We spend so much time focusing on the what that's in our food, our supplements, even our shampoo. But as the strange case of soy protein shows us, maybe the most important question we can ask is how?